3 articles about exoplanets, and the articles are actually from the NASA websites, so they're nice and clean, concise, hopefully true facts and things like that. The first one is just a reading about observing exoplanets. It's a little bit older, but it's kind of relevant if anyone watching this doesn't really follow much exoplanet news. This first article will help you get started, and then the next one is some news about TRAPPIST-1, everybody's favorite star system, maybe. Well, second favorite. And then the other one is a new story, very new, about a 6-star system, so with lots of eclipses. So that's pretty exciting. So I'm just going to jump right into it and start reading, and we'll see what we can learn from NASA's Exoplanet Exploration, Planets Beyond Our Solar System. This was released October 28th, 2019. Observing exoplanets, what we can really see. Exoplanets are far away, and they often obscured by the bright light of the stars they orbit. So taking pictures of them the same way you'd take pictures of, say, Jupiter or Venus isn't easy. The major problem astronomers face in trying to directly image exoplanets is that the stars they orbit are millions of times brighter than their planets. Any light reflected off of the planet or heat radiation from the planet itself is drowned out by the massive amount of radiation coming from the host star. It's like trying to see a firefly flitting around in a spotlight. I never thought about it like that. So it takes new techniques and advancing technologies to make it happen. So this is just so neat, this video. I saw this morning, actually. Watching 4 planets in orbit. So this is a star. I'm not sure if this is one that we can visibly see, probably in the night sky, 129 light years away. And these are planets going around it, the little stars here that we can see. Oh, there might be one. Oh yeah, there's one over here. So yeah, little bits of solar systems or star systems around it. Oh, they have a little star in the middle to show that it's the star. That's cute. Oh wow, that's just so neat. An actual other star system out there, and we can see planets just kind of moving around like they do here. It's like no big deal. 4 planets are in orbit around a star 129 light years away in the constellation of Pegasus. Credit Jason Wang and Christina Morales. That's just so amazing. I did not actually know we had images like this of exoplanets. I knew we had the dips in light and the wobbles and the graphs and stuff, but this is just amazing. Here, the black circle in the center of the image is part of the observing and analyzing effort to block the blinding light of the star and thus make the planets visible. So that's the black circle you see in the middle. It's just covering up the brightness of the star so we can actually see it. So it's not quite so much like looking for a firefly in a spotlight. Thus making planets visible. 4 planets more massive than Jupiter can be seen orbiting a young star, HR 8799, in a composite of sorts. Oh, well, I was hoping it was a straight image, but it's a composite, still cool. It includes images taken over 7 years at the W.M. Keck Observatory in Hawaii. The images were initially captured by Dr. Christian, I thought that said Mario for a second, Marois of the National Research Council of Canada's Herzberg Institute of Astrophysics. The movie animation was put together by Jason Wang, part of the Berkeley arm of the Nexus for Exoplanet System, the NASA-sponsored group formed to encourage interdisciplinary exoplanet science. The star, HR 8799, has continually played a pioneering role in the evolution of direct imaging of exoplanets. In 2008, the Marois group announced discovery of 3 of the 4 8799 planets using direct imaging for the first time. first exoplanet directly imaged. This was the first planet that we saw that we were like, that's not here. So that's really neat. I had not seen that before, and I just kind of wanted to share it because it's just really amazing to think about when you look up at the stars that, you know, Jupiter's or, you know, Jupiter planets could be going around it, or Earth-type planets, you never know. This composite image shows an exoplanet, the red spot on the lower left, orbiting, so probably the planet was one image and the star was another, and they put it together. It's cheating a little bit. I'll let it slide. It's fine. The red spot on the lower left, orbiting the brown dwarf, 2M1207 Centauri. This photo of the exoplanet, that B, is based on 3 near-infrared exposures in the H, K, and L wave bands with the NACO Adaptive Optics Facility. Oh, geez, this is like a lot of technical information.
I can see why they would use that star. Brown dwarfs are not really stars in the conventional sense of like our sun.
Yeah.
They're kind of like failed stars.
So they're not like as bright to wash out the...
Yeah, they glow mostly in infrared.
Okay.
And so they don't have like they don't have that blinding light that overpowers the planet.
So not necessarily a good star to find life around, but good star to find planets around, maybe?
Yeah.
Okay. Near infrared exposures. In 2004, the first exoplanet imaged directly was 2M1207b, four times more massive than Jupiter. European Southern Observatory astronomers using the VLT, Very Large Telescope in Chile. This composite image shows the exoplanet formerly shown as 2 Mas, all of that, B, the red spot on the lower left orbiting the brown dwarf. I think that's what. It orbits a failed star at a distance 55 times greater than Earth from the Sun, nearly twice as far as Neptune. So it's not really a habitable zone type planet. Well, yeah, so, but it's there. Planets that are far from their stars can be seen easier to directly image because they're less obscured by the light from their stars. The system M1207 is 170 light years from Earth in the constellation of Hydra. The photo is based on near 3 infrared exposures in the H, K, and L wave bands. Wait a minute. Okay, I was going to say that's not an exoplanet.
I don't know what the H, K, and L wave bands are, but there's like specific frequency ranges that they're looking at.
Like sort of like colors of infrared, but not really. Just like sizes of lengths. Okay. Yeah, at first I thought that was an exoplanet, but we don't have images like this of exoplanets.
Artist conception.
And that's what I'm used to seeing. That's why it was so cool to see those actual images of them.
Yeah.
You know, there's bright blobby things, but so was Pluto at one time. So, you know, and now we can see the surface of it.
We had to send something over there.
Yeah.
And we might send stuff to these things.
We did have to send something. Yeah, there's an artist's conception of what they think the planet looks like. It looks quite a bit like Jupiter, according to the artist. Hubble's image stability, high resolution, and high contrasting imaging capabilities allowed astronomers to precisely measure the planet's brightness changes as it spins. The researchers attribute the brightness variations to complex cloud patterns in the planet's atmosphere. So it could be much like Jupiter. The Hubble measurements not only verify the presence of these clouds, but also show that the cloud layer are patchy and colorless. Okay. That's a lot of information for just that big old blob. Neat. So that's exoplanets, a small gist of them. And now let's find out what's happening with TRAPPIST. This was, I want to say 2017, 18 maybe?
Might say in the article.
When this was discovered, and it was very exciting, and 7 planets in the habitable zone. Oh my goodness, they could be Earth-like. And this is their both from what I know, the latest it came out January 22nd, 2021. The 7 rocky TRAPPIST-1 planets may be made of similar stuff. So Measuring the mass and diameter of the planet reveals its density, which gives scientists clues about the composition. Scientists know the density of the 7 TRAPPIST-1 planets with a higher precision than any other planets in the universe? Oh, other than those in our own solar system. Keep reading. Okay. So this one's a little smaller. We were having some sizing issues, but it's there. I'm just gonna get all up in my mug. Okay. Precise measurements reveal that the exoplanets have remarkably similar densities, which provides clues about their composition. The red dwarf star, TRAPPIST-1, is home to the largest group of roughly Earth-sized planets ever found in a single stellar system. Solar system, but we can't say solar because sun, so stellar system. Located about 40 light years away, these 7 rocky siblings provide an example of the tremendous variety of planetary systems that likely fill the universe. So the ones from the other article were Jupiter-y looking, and these are possibly Earth-ish. A new study published today in the Planetary Science Journal shows that the TRAPPIST-1 planets have remarkably similar densities that could mean they all contain about the same ratio of materials thought to compose most rocky planets like iron, oxygen, magnesium, and silicon. But if this is the case, the ratio must be notably different than Earth's. The TRAPPIST-1 planets are about 8% less dense than they would be if they had the same makeup as our home planet. Based on that conclusion, the paper authors hypothesized a few different mixtures of ingredients could give the TRAPPIST-1 planets the measured density. Okay. Some of these planets have been known since 2016, when scientists announced, 16, wow, that's longer ago than I thought, when scientists announced that they'd found 3 planets around the TRAPPIST-1 star using the Transit Planets and Planetesimal Small Telescope TRAPPIST in Chile. I thought TRAPPIST was the name they named. Oh, I didn't know that. Okay. Subsequent observations by NASA's now retired Spitzer Space Telescope in collaboration with ground-based telescopes confirmed 2 of the original planets and discovered 5 more. Managed by NASA's Jet Propulsion Laboratories in Southern California, Spitzer observed the system for over 1,000 hours before being decommissioned in January 2020. NASA's Hubble and now retired Kepler Space Telescope have also studied the system. So, these are just little videos of, oh, okay, so you can go in and, oh, wow, okay, so these are artists' interpretations of what they think the planets could look like. I know that some of them, at least, were tidally locked, so like the moon, one side would always be facing, so, you know, there's
I think all of them
are they all?
Would be that way.
Okay,
So
I know at
they're
least
pretty
one or
close.
2 of them is.
That website, or that little segment that shows you the solar system is part of NASA's Eyes on Exoplanets, where they have all the exoplanets they've discovered, kind of simulated in that same way. It's a neat
Yeah.
website.
So you think all of them could be tidally locked?
I think they all are probably.
Either way, even if it's just a couple of them, 7 habitable zone-ish. The star is, it's closer to the star, so they're exposed to more radiation. But maybe these things are super. If there's aliens on them, they can live with so much radiation or something.
Yeah. And even if it is tidally locked, there's still a possibility that it's kind of like called an eyeball planet, where the side that's facing the star is an ocean, and then around it you have that ice sheet. But along the edges, like where the Terminator
zone.
Around the Terminator, there would be kind of like a more habitable area of that planet if it were possible.
Yeah. So like if one side is exposed to space and cold and the other side's always exposed to the star and warm, that little middle part might be kind of interesting.
It's like the 3 bears and that lady who broke into their house.
Oh yeah, what was that called again? Goldilocks or something? All right. All 7 TRAPPIST-1 planets, which are so close to their star that they would fit within the orbit of Mercury, much closer because the star is not as hot. So that's why the habitable zone is closer, were found via the transit method. Scientists can't see the planets directly. They're too small and faint relative to the star. So they look for dips in the star's brightness created when the planets cross in front of it. Repeated observations of these starlight dips combined with the measurements of the timing of the planet's orbit enabled astronomers to estimate the planet's masses and diameters, which were in turn used to calculate their densities. Previous calculations determined that the planets are roughly the size and mass of Earth, and thus must also be rocky or terrestrial. Well, I don't know. Maybe. I thought we had more proof than that. As opposed to the gas dominate, yeah, like they're fluffier, so even though they're bigger, they're okay. The new paper offers the most precise density measurements yet for any group of exoplanets, planets beyond our solar system. Iron's rain. The more precisely scientists know a planet's density, the more limits they can place on its composition. Consider that a paperweight might be about the same size as a baseball, yet is usually much heavier. Together, width and weight reveal each object's density, and from there it is possible to infer that the baseball is made of something lighter, string and leather, and the paperweight is made of something heavier, usually glass or metal. The densities of the 8 planets in our own solar system vary wildly. The puffy gas-dominated giants, Jupiter, Saturn, Uranus, and Neptune, are larger but much less dense than the 4 terrestrial worlds because they're composed mostly of lighter elements like hydrogen and helium. Even the 4 terrestrial worlds show some variety in their densities, which are determined by both a planet's composition and compression due to the gravity of the planet itself. By subtracting the effect of gravity, scientists can calculate what's known as a planet's uncompressed density and potentially learn more about the planet's composition. Lots of math, sounds like to me. So these are the TRAPPIST planets, the B, C, D, and these are comparisons of...
Yeah. They're going left to right. They're just showing how far away they are from their star.
Oh, okay. I thought they were still talking about densities here. Okay.
Yeah, the density is the up and down, I think.
Ah, okay. The up and down. Oh, like, okay.
So Mercury is higher density.
Okay. Ah, I got you. Okay. Okay, yeah, these are all pretty close to the same. Okay, a planet's density is determined by the composition as well as its size. The 7 TRAPPIST-1 planets possess similar densities. The values differ by no more than 3%. This makes a system quite different from our own. The difference in between density in TRAPPIST-1 planets and Earth and Venus may seem small, about 8%, but this is significant on the planetary scale. For example, one way to explain why the TRAPPIST-1 planets are less dense is that they have a similar composition to Earth, but with a lower percentage of iron, about 21% compared to Earth's 32% according to a study. I mean, I could buy that. Alternatively, the iron in TRAPPIST-1 planets might be infused with high levels of oxygen, forming oxygen oxide or rust. The additional oxygen would decrease the planet's densities. The surface of Mars gets its red tint from iron oxide, but like its 3 terrestrial siblings, I love it when they make planets families, but with its 3 terrestrial siblings, it has a core composed of non-oxidized iron. By contrast, in the lower density of the TRAPPIST-1 planets were caused entirely by oxidized iron, or I think. I don't want to stretch it because it's fussy with the sizing. Were caused entirely by oxidized, I can't get the word out, oxidized iron. The planets would have to be rusty throughout and could not have solid iron cores. Oh, really? Is that what they're saying they are? Rusty balls in their core? Okay. Eric Egel, an astrophysicist at the University of Washington and lead author of the new study, said the answer might be a combination of the two scenarios, less iron overall and some oxidized iron. The team also looked into whether the surface of each planet could be covered with water, which is even lighter than rust and which would change the planet's overall density. If that were the case, water would have to account for about 5% of the total mass of the outer 4 planets. By comparison, water makes up less than 1/10% of Earth's total mass. Does it really? Wow. Okay. Isn't there more water in Europa than on Earth? That's so weird to think about. I think about Earth being so full of water. Because they're positioned too close to their star for water to remain a liquid under most circumstances, the 3 inner TRAPPIST-1 planets would require hot, dense atmospheres like Venus, such that water could remain bound to the planet as steam. But Egel says this explanation seems less likely because it would be a coincidence for all 7 planets to have just enough water present to have such similar densities. Oh, a space mystery. Why are they all the same? And why are they so different than Earth? No core, mantle and core, ocean mantle. So I think that, they're just showing the differences of what they could be made of to make up for their density discrepancies that would make them different than Earth. That's neat. The night sky is full of planets, and it's only been within the last 30 years that we've been able to start unraveling their mysteries, said Caroline Dorn. Oh, I wonder if she's related to Worf. Said Caroline Dorn, an astrophysicist at the University of Zurich, and a co-author of the paper. The TRAPPIST-1 system is fascinating because around this one star, we can learn about the diversity of rocky planets within a single system. That is neat. She's right. And we can actually learn more about the planet by studying its neighbors as well. So this system is perfect for that. JPL, a division of Caltech in Pasadena, California, managed the Spitzer mission for NASA Science Mission Directorate in Washington. Science operations were conducted at the Spitzer Science Center, and all the big Spitzer was very involved. Spacecraft operations were based in Lockheed Martin Space in Littleton, Colorado. So neat. So the news on the TRAPPIST systems is that they are, what did it say, 8% less dense than Earth, but they think they're rocky planets, much like Earth. They're just trying to figure out why they would be less compact. What other stuff they might be made of. All right, and here's the one that came out. Was this yesterday? This might have been yesterday.
January 27th?
Yesterday, maybe the day before. Sometime. These days are all so blended together. So this one is just beautiful to think about. This is from Exoplanet Exploration, Planets Beyond Our Solar System. Discovery alert! First 6-star system where all 6 stars undergo eclipses. So that would be very beautiful to see. By Janet Kazmirczak. NASA's Goddard Space Flight Center, Greenbelt, MD.
I think that's Maryland.
MD. Tests previously revealed that Thuban, a former North Star, is also an eclipsing binary, as illustrated here. 3 such pairs make up a newly discovered sextuplet star system called TYC7037-89-1. Credit NASA's Goddard Space Flight Center, Chris Smith,
So,
USRA.
TESS is the Transiting Exoplanet Survey Satellite. It's the one that's kind of taking over for Kepler.
Okay.
And the reason why they say it's a former North Star is because the Earth's axis wobbles over 26,000 years, called precession. And right now the North Star is Polaris, but as you move forward or backward in time, the Earth's north pole will wander across the sky and point at a different star. And at some point, it was pointing at.
That's
Thuban.
pretty neat. So we can still we can still see this star. It's just not considered. It's not.
Yeah, it'll be close to the North Pole, but it's not going to be on the North Pole right now.
How long ago was that?
For Thuban, I don't know.
Thuban. I like that name. Thuban. So former North Star. Yeah. All right. 6-star system. The Discovery TYC 7037-89-1 is the first 6-star system ever found where all the stars participate in eclipses, a discovery made by NASA's Transiting Exoplanet Survey satellite TESS. The system is located about 1,900 light years away from the constellation Eridanus. Man, I see so many constellations, I don't know how to read doing these. It's really good for me, probably. Eridanus. Key facts. The system, also called, in case you heard it by its TIC 168789840, is
like a phone number.
so many things, is the first known sextuplet composed of 3 sets of eclipsing binaries, stellar pairs whose orbits tip into our line of sight, so we observe the stars alternatively passing in front of each other. Each eclipse causes a dip in the system's overall brightness. Astronomers designate the binaries by the letters A, B, and C. The stars in the A and C systems orbit each other roughly every day and a half, and the 2 binaries orbit each other about every 4 years.
These are pretty close.
Yeah. And planets going around it, it'd look neat.
Yeah.
They're pretty close, yeah. The B binaries members circle each other about every 8 days, but the pair is much further away, orbiting around the inner system roughly every 2,000 years. The primary stars in all 3 binaries are all slightly bigger and more massive than the Sun, and about as hot. They're bigger and more massive and about as hot. The secondaries are all around half the size, the Sun's size, and a third as hot. Oh, look, they did a graph. Neat. So here, wait. Oh, wow. So they just...
Each pair has a big star and a smaller star.
Huh.
It looks like.
And I wonder if they both would have planets. Would the big ones and the little ones have planets, or just the big ones? And would the little ones, would it be considered a moon?
it would be difficult to have planets with all of these stars moving around each other so closely. It's like very rare, I think, to have this many, or even just the 6 stars stably orbiting each other for a long period of time. But there's certain like kind of configurations where it is likely to, or more likely to stay stable.
Yeah.
So I guess this might be one of them.
Maybe there's 1 or 2. I mean, there may not be a lot, but I mean, how would you even define your system? I guess
that's why they have all those names and numbers.
Yeah. Oh boy. Okay. This schematic shows a configuration of the sextuple star system. That guy, TYC. The inner quadruple. Quadruple is composed of 2 binaries, A and C, which orbit each other every 4 years or so. The outer binary B orbits a quadruple roughly every 2,000 years. All 3 pairs are eclipsing binaries. The orbits shown are not to scale. Credit NASA's Goddard Space Flight Center. Details. Scientists use the NASA Center for Climate Simulations Discover supercomputer at NASA's Goddard Space Flight Center to chart how the brightness of around 80 million stars observed by TESS changed over time. They then analyze the data using autonomous. Oh yeah, like independent, right? Using autonomous software trained to recognize the telltale brightness dips of eclipsing binaries. Among the 450,000 candidates, research identified at least 100 with potential potentially 3 or more stars, including the new sextuple system. Fun facts. We astrophysicists are very interested in eclipsing binaries because their structure aids detailed measurements of the star's size, masses, temperatures, and separation, as well as the distance to the system. They can use this information to build better models for star formation and evolution. For example, in the case of TYC, those one scientists want to learn more about how the primary and secondary stars across the 3 binaries developed such similar properties, and how the 3 systems became gravitationally bound. What's the fun facts in there? What were they saying?
They get to build better models.
Oh, okay.
And make more graphs.
Okay. So, measurements, temperatures, the distance of the star system. Yeah, it's a neat system. I'm not sure what takeaway fact I can get out of that, though. The discoveries. An internal team led by data scientist Brian P. Powell and astrophysicist Veselin Kostov at Goddard made the discovery using test data. The researchers incorporated archival measurements and also obtained follow-up observations with ground-based facilities. That's unusual. Well, I guess we're not doing exoplanets, it's a star system. The core team includes Sir Sol Rappaport at MIT, Thomas Orokovits at the University of Szeged in Hungary. Oh, goodness, I'll try. Petar Zeshi at Charles University in Czech Republic, and Andrei Takavini at NSF's NORLab. The paper TIC 168789840, a sextuply eclipsing sextuple star system, has been accepted by the Astronomical Journal. A preprint version is available online. That's quite the name. That's pretty neat. Quick rating about exoplanets using the NASA websites. A lot cleaner articles. Not as interestingly written as Planetary Society, but it's still pretty good. So that's about all.
Okay.
I don't really have any more to read tonight, but we'll do another one next week.